Alright guys, today I want to introduce you to two variable inequalities. Okay, now we need to recognize a couple of things that will help us understand what this will look like. Number one, since it's an inequality, what does that mean? Hopefully you remember that an inequality will usually have a range of answers, right? When we did it on a number line, we graphed a whole side, we had an arrow showing it could be anything bigger than this, so we had a range of answers. That will be the case for these as well. Secondly, there's two variables. When we saw two variables before, how is that different than having one variable? Hopefully you remember when we had one variable, we solved for a particular answer. When we had two variables, we solved for, again, many different answers where different x's and different y's could then give us a solution or something that worked in the equation. Remember, what we're trying to do is find the sets of x's and y's that work to make the equation true. Okay, that's what a solution is. Now, when we did it with the equal sign, we were graphing lines, remember? And the line represented all the points that worked or that were true for that equality. So now what we're going to do today is I'm just going to try out a couple of points. We're going to plug them in, and we're going to look at what the solution set of this looks like. Okay, for example, if I plug in the number -6, -6. Okay, remember this is my x value, this is my y. I'm going to put in x there, I'm going to put in y there. Okay, so -6 is less than half of -6 plus 1. So now -6 is less than half of -6 is -3. Okay, -3 plus 1 is -2. And so then we can say -2 is bigger than -6. This is true. Okay, so somehow I need to represent that -6 makes this equation true. So what I'm going to do right now, just to kind of simplify things, I'm going to go ahead and draw a graph, because that's what we did with two variables before. We had to demonstrate an x, we needed to also demonstrate the y, and because of that, we had then this coordinate plane that allowed us to do both x and y, right? Here's x, here's y. So -6 needs to be a solution. Now what I'm going to do temporarily is I'm going to use blue, and down at -6, I'm going to put a blue point because that's true. Now I'm going to try a couple other points. Actually, what I'm going to do is I'm going to cheat a little bit because I've done this already. I worked out a whole bunch of these ahead of time. You don't believe me? Just try it out on your own. But I worked out a whole bunch of these in which I tested a whole bunch of other points. And so, for example, -6, -3 was true. When I put those numbers in, it gave me a true statement. So I'm going to put down -6, -3. That's a true point. Now, blue will be true. A false point, for example, -6, was false. So if I do -6, I'm going to do that one in red to show that it's false. Okay, so I'm going to pause it for a second. I'm going to magically appear with all the points just to kind of simplify things. Alright, now what you should see here is the results of me plotting this. Okay, all the trues in blue, all the false in red. And you can see that there's a definite pattern. Okay, something that's happening here that you can almost see that there's all the falses up here, all the trues down here. You can probably guess that a point somewhere over here, if I plugged that in, I would get true as well, right? And so what I want to do now is I'm going to go ahead and show you what happens if I graph y equals 1/2 x plus 1. So I just changed the inequality to an equal sign really quick. Okay, so I'm going to go ahead and graph that. So I have y equals mx plus b. b, the y-intercept is 1. And then I'm going to go up 1 and over 2. Up 1 over 2. Up 1 over 2, right? Those are the points on my graph. Down 1 over 2, down 1 over 2. Okay, so there you go. There's the points on your line. You'll notice that that cuts it in half, all the reds above, all the blues below. Now, when I draw my line, I'm actually going to use a dashed line. The whole reason for that, remember the line is supposed to show the solutions. It's supposed to show the numbers that work. Now, if y is equal to 1/2 x plus 1, is y going to be less than 1/2 x plus 1? Of course not. It's equal, not less than. So I'm going to show a dashed line saying, now the points on this line don't count, but anything below it does. Okay, now to show that anything below it works, I'm actually going to shade in the region, this whole area, just like this. Now in the next video, I'll do a couple more videos and go through this a little bit quicker, but that's the whole idea behind it. There you go.